Now we are going to discuss on half-wave controller rectifier with a RLE load. So RLE load, you can just imagine it as a DC motor. So the back EMF is indicating nothing but your EMF E. So here, this section is nothing but your E, and therefore first we will be trying to fire the thyristor, and then we will be observing how the output voltage waveform is. So I need your attention to your angle θ1 over here. So this angle θ1 is nothing but the intersection of your source voltage Vs with your EMF E. Source voltage Vs with your EMF E. Now for omega t less than angle θ1, the thing is that the E is greater than your source voltage Vs. For angle omega t less than θ1, E is greater than your voltage Vs. That means the thyristor is in the reverse biased condition. So it is not possible to fire your thyristor at an angle less than θ1. Therefore, our firing angle should be greater than θ1 to get the thyristor to be forward biased and to get fired. So now I am going to fire my thyristor at an angle alpha. Therefore, at the angle alpha, the voltage waveform will be same as the input voltage Vs. So till then your thyristor T. So for the angle less than alpha, and since the thyristor is in the off condition, the output voltage will be remaining at E. So your output voltage will be remaining at E over here. Now at alpha, your thyristor is fired, therefore it will try to follow the waveform of your input voltage. So therefore it starts to increase like this. Now the thyristor will get reverse biased at angle θ2. So, and the thyristor will go to a off state only when the current also goes in the below the holding current. Therefore, if the holding current is for the thyristor, if the thyristor current is below the holding current, then the thyristor goes to the off state. So that can happen at any angle greater than θ2. So the waveform of your output voltage will be going like this, and it reaches the angle pi. So at angle pi, what happens? The voltage is getting reversed, and that time your current will not be reaching to 0 because this is a inductive load. Therefore, the current waveform, I can plot it like this. So if this is I0, the waveform for your current can be plotted like this. And when reaching the pi, the current I0 has not gone below the holding current, and therefore because of the lagging nature of your current, the thyristor will not get turned off. So, and at another point of time, at an angle beta, what happens? The current reaches to 0, and therefore the thyristor gets turned off. So therefore your output voltage will also be following the same waveform of your input voltage. So this is nothing but your beta, and this is nothing but your alpha. Now at beta, the thyristor has turned off, and therefore the output voltage again it starts to increase to E, and this will be continuing like this. And again at another angle where it is greater than 2 pi plus θ1, it again gets fired, and moves like this. So that time your current I0 will be increasing like this and then coming down. So now you can see that the output current here it is same as the source current, and therefore I can denote it also as the IS. And this is nothing but E. And the angle at which it is conducting. So this is nothing but alpha, this is nothing but beta, and this is nothing but your conduction angle gamma. Now we need to plot the thyristor voltage also. So we will be plotting Vt, and this is nothing but V0. The thyristor voltage, how we can plot. So for angle less than theta 1, there is a voltage which is acting to the thyristor Vs and another one E. So therefore, the thyristor voltage across thyristor is becoming 0 at angle theta 1. So therefore, this is the point where the voltage across thyristor becomes 0. And when the source voltage Vs is 0, there is a EM of E which is acting across thyristor, so it is minus E. So this is minus E. And then it gradually increases and it reaches to this point. And during at this time, the thyristor starts conducting. So during the angle alpha, conduction angle, the thyristor voltage will always be 0. Then it is again goes in the reverse direction, and there is a Vm plus E will be the voltage which is the maximum voltage will be appearing across your thyristor. So this will be the thyristor voltage. So this is the total working principle of the system when the load is an RLE load.